Assalamualaikum and salam sejahtera. From this video, we're going to start discussion on our last topic in Principles of Compiler, which is topic 5 on bottom-up parsing. This topic is based on our textbook. Throughout topic 4, we have discussed a type of parsing algorithm called top-down parsing. In this parsing algorithm, our string is parsed from the top of derivation tree to bottom. From this topic, we will discuss bottom-up parsing, where our grammar is parsed from the bottom of derivation tree to up, and the grammar rules are applied in reverse. For example, in top-down parsing, we will start by looking at grammar and listing the string. However, in bottom-up parsing, we look at the string first and we scan the grammar rules for rules that match our string. In bottom-up parsing, we still parse our string using stacks. The method, however, is a little bit different with top-down parsing. It involves two operations. The first one is called the shift operation, where we move an input symbol to the stack. And the second operation is the reduce operation, where the symbols on top of the stack will be replaced with a non-terminal. These two operations are basically doing derivation step in reverse, and because of these two operations, bottom-up parsers are also called Shift Reduce parsers. Bottom-up parsing is also called Shift Reduce parsing. Let's take a look at the steps involved in parsing an input using Shift Reduce parsing. First, we will begin with an empty stack, and then input symbols will be moved to the stack, and this is an application of the shift operation. Next, symbols on the stack will be scanned, and if it matches our rules, it will be replaced by a non-terminals, and this is called the reduce operation. And finally, when all input symbols have been read and the symbol on top of the stack is the starting non-terminal, we accept the string. If otherwise, we reject the string. Let's take a look at how we can parse this input AABB using Shift Reduce parsing based on this grammar. First, we start with an empty stack. Different with top-down parsing, the stack for Shift Reduce parsing are horizontal. So we start with an empty stack and our input is A, B, B and marker. The first operation is always shift operation because currently there is no symbol on top of our stack. Therefore, we cannot do a reduce operation. So what we're going to do is we're going to do a shift operation, and what happens is the first input, which is A, will be shifted into our stack. So we will have A here. And then our input is left with A, B, B, and marker. Okay, next what we're going to do is we're going to look at the symbol on top of our stack. Currently it is a single A, and we will compare it with the right side of our grammar. Since we do not have any single A at the right side of our grammar, it means we cannot do a reduce operation yet. So we need to do another shift operation. So when we do another shift operation, now our stack will have another symbol on top of it, which is A. And our input is now BB and marker. Again, we will compare the symbols on top of a stack, which is now AA, with the right hand side of the grammar. So on the right hand side, we do not have two A's, so we cannot do a reduce operation. So what we're going to do is we're going to do another shift operation. The result of another shift operation is AAB, where B has been moved on top of our stack and our input is left with B and marker. Now when we scan the three symbols on top of our stack, we will notice that on the right hand side of rule 3, there is a single B. And we also have B on top of our stack. Therefore, what we can do is we can do a reduce operation by reducing B with rule 3. So we need to specify our handler. So our handler is the string that we will reduce. So I have already underlined the single B here with the red pen. And then I'm going to specify that I want to do a reduce operation using rule 3. So what is going to happen is we're going to take out the single B, and then we're going to replace it with the symbol on the left hand side of rule 3. So our stack now is AA capital B, and then we are left with still the current input of B and marker. Next, we will scan the three symbols on top of our stack and compare it with the right hand side of our grammar. Here we will notice that we have AB over here, that is also the two symbols on the right hand side of rule 1, which means we can do a reduce operation. So let's write it here, reduced using rule 1, and once we have taken out the symbols on top of our stack, we will replace it with the symbol on the left hand side of our grammar, and that symbol for rule 1 is A. So I'm going to put A here, and we still maintain the current input of B and marker. Next, we scan again our stack if we have anything to be reduced. Since we do not have anything to be reduced, we do another shift operation. So we get bottom marker A, B, and our symbol now, or our input now, is N marker. And then we notice that if we compare the symbols on top of our stack with the right hand side of rule 2, there is two symbols here, which is our handler. Therefore, we can reduce using rule 2, and our stack now has bottom marker A and B, since B is the symbol on the left side of rule 2. Next, if we scan again the symbols on top of our stack, we will notice that AB is the symbols on the right side of rule 1. Therefore, both of these is the handler, and we can do a reduce operation using rule 1, and our stack now will have bottom marker and A, and our input is N marker. Now, because A is our starting non-terminal, which is the non-terminal of rule 1, and the input is N marker, we say that this input has been accepted. And this is how you apply Shift Reduce Parsing using stack. This is a longer example of Shift Reduce Parsing using grammar 19 for the input CAA BAAB. So the first operation is always C. So C is placed on top of the stack. And then we notice that on the right hand side of row 2 there is C. So C is underlined and it is reduced using rule 2. Once it is reduced, the symbol is replaced with the symbol on the left hand side of rule 2, which is S. And then we do another shift operations and we get SA. So SA is scanned and compared with the right hand side of the rule, but it cannot be reduced. Therefore, another shift operation is done. And now we have SAA on top of our stack. Still, we cannot reduce anything. So we do another shift operation and we get SAAB. So with this new stack, and we compare it with the right hand side of our grammar, we notice that AB is the symbol on the right hand side of rule 3. Therefore, AB is underlined and it becomes the handler. And now we do a reduce operation using rule 3. So when we do a reduce operation, we take out AB and we replace it with the symbol on the left side of rule 3, which is a capital B. Then we have SAB on top of our stack, and we notice that SAB is the symbol on the right side of rule 1. So the whole thing becomes a handler and the whole thing is reduced using rule 1. So this whole thing is removed and replaced with S. Okay, next we do another shift operation, and shift operation, and we get SAAB. So if you notice, this is basically a replication of the previous steps we took above. So this is just another reduced operation using rule 3, where these two symbols are taken out and replaced with B. And then we have SAB, which is the right hand side of rule 1. So the whole thing becomes a handler and the whole things are reduced and replaced with S. And since we are left with the starting non-terminal and end marker, we say that the string is accepted by grammar 19. In bottom-up parsing, we are no longer using the concept of LL1 grammar. Instead, we are using LR grammar, in which the parser reads an input from the left while finding a rightmost derivation. Therefore, LR grammar are grammar that can be parsed using Shift Reduce Parser. There are two types of conflict that can happen in Shift Reduce Parsing. The first one is called Shift Reduce conflict. In Shift Reduce conflict, it happens when our parser does not know whether to do a shift operation or a reduce operation. When this happens, we say that this grammar is not an LR grammar. Therefore, we must either rewrite the grammar or use a different parsing algorithm. This is an example of a shift reduce conflict for this input string AAAB, and we will use grammar 20 to try and parse this string. So the first thing that we do is shift, and then we reduce using rule 2, and then we shift, and when we get SA, here the parser will be confused whether to do another shift operation or to do a reduce operation. So if the parser choose to do a reduce operation, finally the parser will determine that there is a syntax error or the input string is rejected by grammar 20. When by right, this input string should have been able to be accepted by grammar 20 if in this particular step, instead of reduce, we do a shift operation. But since our parser is not capable of determining whether to do a shift operation or a reduce operation, we say that this is a shift reduce conflict. Another type of conflict that can happen in shift reduce parsing is called a reduce conflict. This is the second type of conflict. Reduce conflict happens when it is clear that we need to do a reduce operation, but the parser is confused which rule should be applied when doing the reduce operation. Grammar that cause reduce conflict is ambiguous and certainly not LR grammar. This is an example of reduce conflict for the string AA using grammar 21. So the first operation is always shift, and once we have shifted A on top of our stack, we face a reduce conflict. Because if you look at the right hand side of grammar 21, there are A's for both rule number 2 and rule number 3. Therefore, the parser is confused whether to reduce using rule 2 and replace it with est, or reduce it with rule 3 and replace it with A. So if the parser chose rule 3, it will be incorrect, since at the end, the symbols that are left on top of our stack are 2 symbols and not only a single non-terminal symbol est. However, if the parser has chosen rule 2 over here, this string AA would have been able to be accepted by grammar 21. But since this grammar is ambiguous and makes it confusing to the parser, we say that this grammar is not LR. How do we resolve the two conflicts, shift reduce conflicts and reduce conflicts? One, we can make an assumption. So for example, this is especially true for shift reduce conflict. If whenever we face conflict, we always choose shift will make the string be able to be accepted, we can program it into our parser to always shift. Therefore, we do not need to rewrite the grammar. The second way to resolve is to rewrite the grammar. And the third way is to look ahead at additional input character. If currently we are looking ahead at only one input in front, we perhaps can modify our parser to look at 2 or 3 inputs ahead, so that the parser would be able to choose which rule to apply better.